And good morning, campers. As you can see, we're spinning our TRD gearbox here. We currently have our inverter prototype connected here to NG2. We're running it at 5 Hertz. Again, keeping in mind that these are internal permanent magnet motors, so they are a synchronous machine. Now, what does that mean? Well, a synchronous motor, in my simple terms, is one whose rotor speed exactly follows that of its stator speed. So there is no slip in this motor. So 5 Hertz on the stator of this motor is producing whatever the equivalent speed of 5 Hertz being on the rotor. Now, interestingly here, obviously we've got no control signals on the solenoids in this particular box. It's currently in drive. As we might be aware from the last video that I did on this, I don't have an external oil pump here to pressurize the valves. But the fact that we're running like this, and we're actually turning the input shaft, which looks to be at practically the same speed here. I'll give you guys a view on that in a minute. But we will be turning the internal mechanical oil pump in the box. So the reason you might see some rags around here is I'm kind of afraid that I'll hit a certain speed here and all of a sudden I'll have hydraulic fluid coming flying out through this port. But it really depends upon how the internal pathways are set up inside the box, whether there's a non-return valve here to stop that happening. I kind of suspect there should be, but as to whether Toyota designed that to be inside the gearbox or inside the pump, I don't know, but I guess I'm going to find out. So right now we're at 5 Hertz. We had some fun getting it to start. It was basically jumping as I was tweaking some of the values, but let's take our frequency up a notch to 6 Hertz. You can see our current on the fluke now on the DC bus is running at about 128 volts from our trusty Renault Fluency battery here. And we're at about 0.8 amps on that right now according to the fluke. Let's go for 7 Hertz. And 8 Hertz. Let's go for broke, 10 Hertz. Now drawing 1 amp. Kind of gear-like sounds coming from it. No vibration whatsoever. Some oil sloshing sounds. I'm not actually sure if there is oil in this guy, but I don't think it'll come to any harm just for a few minutes at low speeds without any load on it. Let's try 11 Hertz. Well, motor now, alright. If I can find a way to do torque control on this baby, I think this could become interesting. Let's try 14 Hertz. Still at 1 amp. No sign of any oil seeping out of this port here. Hertz. No heating in the transistors at all, there shouldn't be really. We're only putting like 1 amp at 130 volts is only 130 watts, so. Alright. 16. 17. 18. Nearly spinning now. Interestingly, our current has dropped a tiny bit. I'm just doing this very gently because I have no idea how it's going to react. 19. Oh, thank you, Fluke. That's helpful. Yeah, I'm getting a bit of an error in that now. 0. Thank you. Let's try 20 hertz. I know I'm crazy, right? I know to most people it's probably like watching paint dry, but this is quite exciting for muggins here, so you're just going to have to either click forward and wait till I get to a part where it goes pop, or go watch a cat video. Let's try 22 hertz. Interesting, we're still not drawing any more current than we were at the lower frequencies. 24 hertz. Still no oil leaking out, which is good. 26 hertz. It's just not even, I didn't even know that was running if I put my hand on it. .28 hertz. Tiny bit of inverter whine I can hear from it. Now switching at 8 kilohertz. 30 hertz. Still 1 amp. Well, this is kind of good because I got a Japanese battery and a German inverter with Japanese transistors, and now I've got a Japanese gearbox, so I'm fairly motoring up here. I can kind of notice now that my input shaft spinning here is very slightly noticeably slower than the output shaft. .32 hertz. .34. 35. Still nothing. Trying to go boom shakalaka. 36. 38. 40 hertz. 'm beginning to think there's no oil in this thing. I'm going to have to check that out. Good job, Miroslav sent me the Lexus service manual stuff, so I'm going to have to get into that pretty soon. 42. 44. Okay, I'm hearing some different sounds now. Probably getting up to speeds where certain things are going to start happening inside the box. Most noticeably probably a minimum pump speed, which is the part that worries me. That's, my floor is going to get wet. 46 hertz. 48. 50 hertz. 1.2 amps now. Slightly more power, I guess, to turn against whatever's in there. Oops, that's a bad sign. Okay, as usually happens in these affairs, I think I'm going to need some new pants. I would imagine that we just got ourselves somewhat outside of our control envelope there by cranking up the frequency without cranking up the current. So obviously something just wasn't very happy and shut down. But I suppose a bit of a good thing in that it didn't do us any particular harm. So just goes to show we've got a lot of learning to do with this internal permanent magnet motor stuff that we got here. So that is MG2, and as you'll know from the video I did there with the well, my rather poor kind of screen recorder video there, we know how the planetary gear system works. But while we're here, why don't we swap the wires over to MG1 and see what happens there. So stay with us. Now, as I'm sure you guys were paying close attention to our video about the makeup of this particular gearbox, you will know that in the Lexus application, MG1 is used for two purposes. It's used for engine starting and as a generator to charge the rather crappy nickel metal hydride battery that they put in there. So we're hooked up on MG1, we're still in drive, and I'm going to try some settings here which hopefully won't cause us a problem. So we'll stick with amp nom at 50% and we'll try 5 hertz. What do you know? Spinning! Yay! Wow. Now, of course, it has no desire to spin the output shaft because of the fact that it's spinning this guy. But what if we locked this shaft? Ooh, that could get interesting then. Let's take the frequency up a notch. There's 10 hertz. Ooh, interesting. It's drawing a lot more current than MG2. I've got 1.6 amps on my DC bus. Probably the different characteristics of that motor. Make it, I'm going to take amp nom up to 60% here because, ooh, it doesn't like that. It's too high. 40%. That's a lot better. Interesting. My amp nom setting was way too high for that motor. And now at a much more happy 0.4 amps. Interesting stuff. Let's try 15 hertz. Yeah. Not very visible there. I probably should have a piece of tape on it or something like that. Of course, it's red. Red for danger. There you go. That should make things much more exciting. Let's try direct start to 15 hertz. Oh, it doesn't like that. Let's try 5. I'm going to take a jump to 10 right now at that. So there you go, folks. That would be MG1 doing some MGing. Right, probably bored you guys enough with all of this stuff. We've got a lot of work to do. So stay tuned. And we'll do more work. And I'll make more videos and drive myself crazy some more. And yeah, that's about it. So thanks for watching. Thanks for watching some spinning of motors. Always very exciting stuff here. And we will catch you guys on the flip side. Stay with us.